Lesson 10D, Probabilities of Multiple Events. This is your last set of video notes for Algebra 2. Okay, I want you to stop the video a minute and look at this first example where it says getting ready. You and your friend take turns rolling two standard number cubes. If you roll a sum that's either odd or prime, you score a point. If your friend rolls a sum that's both odd and prime, she scores a point. I want you to think about this and write out an explanation of what you think the answer is right here. Your teacher will be checking to see that you have done that. Okay, hopefully you've got a good answer there. So let's move on. When we talk about occurrences of events, they're either independent or dependent. If one event affects how the second event can occur, we say that these events are dependent, because the outcome of one depends on what the outcome of the other one was. Otherwise, they would be called independent. So let's look at some examples. Okay, you roll a die, then you spin a spinner. This would be independent because it doesn't matter what you got on the die. Your choices are still the same for the spinner. You pick one flashcard, then another one from a stack of 30 cards. Without putting that first one back, your chances for the second one have changed. That makes this dependent. So to figure out the probability of two events, if they're independent, all we need to do is figure out the probability of each one and multiply. So as long as you've determined that these are independent events, the probability that A and B both occur would be the probability of A times the probability of B. So let's look at a couple examples. At a picnic, there are 10 diet drinks and 5 regular drinks. There are also 8 bags of fat-free chips and 12 bags of regular chips. You're going to grab a drink and a bag of chips without looking, and so we want to look at the probability that you get a diet drink and fat-free chips. So let's start with the drink, and then we're going to figure out the chips. First of all, is this situation dependent or independent? No matter what drink you have, that does not change your choices on the chips. So this is an independent situation. All right, so for a drink, there are a total of 15 drinks, and of those, 10 would be diet. For the chips, there's a total of 20 bags of chips, and 8 of those are fat-free. So to calculate our probability, we're going to multiply these. So we're going to get 80 out of 300, and we can reduce that to 8 out of 30, which reduces further to 4 out of 15. So your probability of getting the diet drink and fat-free chips would be 4 out of 15. Stop the video at this point, and I want you to go do B. This is a try me, so do this before your teacher checks your work. Okay. Two events that cannot occur at the same time are called mutually exclusive. This means that if one event occurs, the other event cannot occur, and vice versa. So if A and B are mutually exclusive, then the probability that they both happen would have to be 0. So let's think about this. If we roll a die and we roll it one time, we want to think about whether or not these are mutually exclusive. Is it possible if you roll the dice one time to get both a 2 and a 3? It's going to land on only one side, so these two would be mutually exclusive. If you get a 2, it means you can't get a 3. If you get a 3, it means you can't have gotten a 2. So let's look at the next one. You roll an even number and a multiple of 3. Well, let's think about this for a minute. If you roll a 6, that is both even and a multiple of 3. So in this case, those two events would not be mutually exclusive because it is possible to do them both simultaneously. So the probability of A or B depends again if they're mutually exclusive. So if it's A or B, we do the probability of A plus the probability of B, But then we have to subtract out the probability that they both happened, because we would have included that twice in the A and the B. If they're mutually exclusive, the probability of A and B is 0, so that takes that last part out of the equation, and we just have to add together the two probabilities. So at Panther High, a student can only take one foreign language each term, which means that taking Spanish and taking French would have to be mutually exclusive. So 37% take Spanish and 15% take French. So yes, these are mutually exclusive because of this phrase right here. If they didn't tell us that, then we would have to consider that it's possible to take both and that it would not be mutually exclusive. But in this case it is, so the probability that a student chosen at random takes either Spanish or French would be 37% plus 15%, which is 52%. And that's how you would calculate that. If they were not mutually exclusive, we would have to know what the percentage was of students taking both, and then we would subtract that out. All right, let's look at the next one. Suppose you reach into the dish and select a token at random. We've got triangular, square, and circular tokens that are yellow, green, orange, and red. So we want the probability that the token is round or green. Well, these are not mutually exclusive because we have some that are both round and green. So we need to be careful. We can simply count these up, and we can say this is green, so it counts. This is round and green, so it counts. This is round and green, so it counts. This is round, so it counts. And this one's round, so it counts. So we have 5 out of the 9 tokens in there would be round or green. Oops, we forgot one up here. This one's also round, so it would actually be 6 out of 9, which reduces to 2/3. So 2/3 of the tokens in the dish would be either round or green. Okay, so let's look at the next part, square or red. So if I look at that, I'm going to erase my marks from the first one. This one would work because it's square. That one's red, square and red, red, square. So this would be 5 out of 9. Stop the video and you go try this one on your own. You should have that done when your teacher checks your notes. Great, let's move on and talk about conditional probability. Conditional probability occurs when your conditions change what you're looking at. Probability that event B will occur given that another event A has already occurred is called a conditional probability. These events are dependent on each other because you have to be in category A to even be in consideration. So let's take a minute and look at the way these usually show up. It's very frequently to see these problems in table format. This table shows the number of students in thousands by gender in 2-year, 4-year, and graduate schools. So when you're working with these tables, the first thing you want to do is get your totals. So if you add 1866, 4324, and 1349, you get 7,539. That's our total of males in any of those. We should be able to do the same thing and get the total of females, which is 9,933. This can give us a total overall. If we add those two, we're going to get 17,472 people represented in the chart at all. We also need to do our sums of our rows. So all the people in 2-year college would be the 1,866 plus the 2,462, which is 4,328. If we add all of those students in 4-year colleges, we get 9,841. All those in graduate schools would be 3,303. If we add those three numbers, it's a quick check on ourselves to make sure we have the right total and we haven't lost anything. So let's look at these probabilities based on these numbers. The first one asks us for the probability that a student is female, given that she is in graduate school. This line right here is read, given that. So we would say the probability a student is female, given that she's in graduate school. So when we go figure this up, the fact that she is in graduate school needs to be the bottom of our fraction, because we only want to look at those students in graduate schools. So we are just looking at this line in our chart. So given that they're in graduate schools, I want to know that they're female. So this is female in graduate school. So when we go set this up, I look at the total number of students in graduate schools, which is 3,303. And then I look of the ones that I've circled, which ones are female, and that would be 1,954. Divide that out, and we're going to do this in decimal form because these are a little messy. And we get about 0.592 or 59.2%. Okay, so let's look at female. If we just want the probability that a student is female, notice we don't have the line, so we're not looking at a subset. We are looking at all of these students. So in this case, our denominator is going to be the full 17,472, and I want to know that they're female, so I'm going to look at the female column right here and take our total there, which is 9,933. Dividing these out, we're going to get 0.569, or about 56.9%. I want you to try this one on your own, and again, your teacher should check to see that that's done. And we'll do this last conditional problem together. So the probability that a student is in a four-year school, given that they are male, means I want male on the bottom and four-year and male on the top. So all of our males, it's going to be this number right here, so 7,539. And of these, so looking only at these people, how many are in four-year colleges? That would be 4,324. So when we divide this out, we're going to get this to be about 57.4%. Okay, let's look at the next example. In this chart, we've got different materials and whether they were recycled or not recycled. Americans recycle increasing amounts through municipal waste collection. The table shows collected data for 2007. We want the probability that a sample of recycled waste is metal, which means I only want to look at the recycled waste. And then I'm going to figure out metal and recycled. Okay, so all of our recycled material is this column right here. That total is 79.4. Of the ones that are recycled, those are the ones we're looking at, the metal recycled. So that would be 7.2. When you divide this out, you're going to get about 0.091 or 9.1%. I want you to try number 11 on your own. This is a try me. And here's your formula. It's just the formula that they are in both categories divided by the formula that they are in the second one. After you do this, you're going to stop the video and we'll talk about tree diagrams in class next time. But you should have your notes completed all the way through example 11.